confirmation about the audio, please? If the audio is clear, thank you. Vandana, as you told that sun is much more bigger and having much energy than planet Earth. If sun is attracting sun towards itself, no. As I told you, Vandana, please understand that sun tries to attract the planet Earth towards itself. It is that force of gravitation due to which there is that consistent falling which happens. But because Earth has got a velocity, it doesn't directly fall into the sun, but it has got that kind of a motion where it tries to fall, but it comes here. Again, it is getting attracted rather than falling directly. It comes here. Rather than falling directly, it has got the velocity, so it reaches there. So it is that simple concept. Okay, right. And why we can see only one side of the moon, Tanishta? That is what is referred to as tidal locking. It again is due to the gravitational attraction of the Earth, and the gravitational pull of attraction by the Earth is so strong that it consistently has one side of it facing it. Just a moment. Okay. Now, an announcement about the feedback forms. The feedback forms would have been sent to you, and whichever subjects you would have attended previously, please do fill the feedback sheets and send it back to us. Okay. Nayana, as I told you, sun is not always attracted. It is not that sun is static. Sun is also in motion, and the planets keep on moving with respect to the sun. So if you think about it, sun has got a motion like this. It moves around the Milky Way, and then the Earth simply, along with the other planets, they keep on moving around the position of the sun. Okay. Why planes are not attracted? Planes are also attracted. That is the reason why planes basically have the speed. When you move in a plane, do you think that the plane is static in the air? It moves at a speed of around 800 kilometers per hour. So 700, 800 kilometers per hour. So it is because of that speed, because of the lift, the aerodynamic lift, that is why it stays up. Cosmos basically refers to the world, the universe around us. Is there any chances of to collide between the Earth and the other planets? No. Each of them have their own orbit, which has been formed as a result. But previously collisions have happened. In fact, when we take a look at the formation of a moon, that was because a Mars-sized object actually went and collided with the planet Earth. So that is how moon came into existence. Okay. Now, that is the case of planet Earth and its motion. And it is not the case that circle of illumination came into existence. At any point of time across the planet, if let's suppose the sun is here, the planet is rotating, only half of the planet will get that light. Remaining half of the planet will be away from the sun. So whichever imaginary line that you can think about, which distinguishes the lighted portion and the darker portion of the planet, that can be considered to be the circle of illumination. Can we assume that other galaxy also had a sun and other planets? You can assume that the other galaxies have millions and billions of sun, and each of them will have their own set of planets. Okay. Why the orbit changes from elliptical to circular? Because of the gravitational pull of the Jupiter. Okay. Now, why most of the planets are circular? Because when you talk about the planets, they consistently rotate. Anything which rotates, for example, take the case of when you make chapatis or when you have a dough. So if you roll that dough continuously in a rotating motion, it forms a circle, isn't it? So the planets, as they are rotating due to the force of gravitation, they will have that. Sun also does rotate. That means planets have three types of motion. Which three types of motion? You are talking about that circular motion, the rotational motion, yes. As the asteroid come out of their belt, as any of this planet come towards us, yes, asteroids have gone through multiple collisions with planet Earth. That is how the life on planet Earth basically almost came to an end 65 million years back, when you had the asteroid which collided with planet Earth, and that is virtually what put an end to the era of dinosaurs. Otherwise, if asteroid would not have collided at that point of time, dinosaurs for all standard purposes would have existed even today. Any object which has got mass will have its force of gravitation. Any object which has got mass will have its force of gravitation. Now, when we talk about planet Earth which rotates from west to east consistently. Now here, first of all, before this, one of the basic aspects, when we talk about a circular motion, when we talk about a circular motion. Now, what is the distance traveled in the circle? Distance traveled by a circle can be considered to be the perimeter of the circle. If let's suppose this is the radius, we do know that perimeter of the circle is 2 pi r, isn't it? That is the radius, or that is basically the perimeter. So if let's suppose an object is moving across this circle, we can say that the distance traveled is 2 pi r. With that basic concept, let us understand one another simple aspect. That is, as the planet rotates on its axis consistently, let's suppose you have an individual who is standing here. Let's suppose you have an individual who is standing here and an individual who is standing here. Okay. Now, let's name each one of them. Let's name this as A. Let's name this as B. Let's name this as C. Now, A, what is the distance that A will travel? If I denote this circle with a radius r, I can say that the distance traveled by A is how much? If I name this geoid here, distance traveled by A in one rotation is how much? 2 pi r. Simple. If I talk about this position B, now what is the distance traveled by B in one rotation? So distance traveled by B in one rotation will be across this circle with a radius, again, let's suppose r1. So distance traveled by B is equal to 2 pi r1. Okay, how many of us are not aware about the about the perimeter of a circle? I hope by now, at this point of time in your life, all of us would be aware about the perimeter of the circle. No? Which class are we in? Have we all, I'm assuming all of us have basically covered at least class 6th or 7th. So you would have covered the perimeter of a square, you would have covered the perimeter of a circle. This portion you would have covered, or even this is not covered. How did you manage to clear the board exams? This is okay. Perimeter is double the radius. Okay. So a kind of, it might be a rude awakening, but in order to clear this prelims examination, in case you want to appear for the mains examination, you will have to clear CSAT, the civil services, the aptitude test, where you have questions of quantitative analysis, etc., which is asked, where basically circumference, perimeter, these are the very base area. These are some things that, if I'm not mistaken, this is something that you would have covered maybe in your class 4th, 5th, or 5th or 6th. But nonetheless, in case you are not aware, distance traveled across a circle is equal to perimeter covered in a circle equal to perimeter. GIB and as Hussain, in which class are we? And perimeter of a circle is equal to 2 into pi into radius. Degree, graduation. Did you appear for the board exams, my dear friends? Nonetheless, and I would be very interested to know. Okay, right, open. Okay, fair enough. Nonetheless, this is the, yes, okay, so 2 pi into radius is the circumference of the circle or the perimeter of the circle. So that is the distance traveled. When you move in a circular path, that is the distance traveled. So 2 pi r is the distance traveled. Okay, so when we talk about this, that a person at A in one rotation, what is the distance traveled? That will be 2 pi r here. Now a person at B, what will be the distance traveled by a person at B? That can always be thought to be 2 pi r1 here, if this is r1, we can think about the distance traveled to be 2 pi r1. Now we do know just by simple appearance sake that r is greater than r1. We can have this understanding that r is greater than r1. Okay. Now, here, what about the person at C? Now, as the planet rotates continuously, the person who is basically stationed at the poles, right? So, what is the distance traveled? Person who is standing at the equator in one rotation will cover the entire distance around equator. Person slightly above at B will cover that distance. What about the person at the poles? As the planet rotates, we can say that the person is almost going to be in the same place as the planet rotates underneath them, isn't it? So basically, can we say that the distance traveled by C will be how much? Can we say it will be close to 0? Are we comfortable with that? Hussain and GIB. Yes, can we say that? Okay. Now, one rotation takes 24 hours or 1 day. One rotation happens in 1 day. That is why you have sunrise in the morning, sunset, then again next morning after 24 hours you have sunrise. So 1 day basically means one rotation. So what is speed? When we talk about speed, what is speed? Speed is equal to distance by time. Are we aware of this formula? This is the formula I think that you study in class 4th. So even your excuse of corona won't work here. Right? So speed is equal to distance by time. So speed of rotation experienced at A is equal to distance traveled by A by 1 day, let's assume. Speed at B, can we say that is equal to distance traveled by B by 1 day? Isn't it? Speed by C, that is speed of rotation of C, is equal to distance traveled by C in 1 day. Time is 1 day here. So we know based upon this that distance covered by A in one rotation is going to be higher as compared to distance covered by B in one rotation, which is going to be higher as compared to distance covered by C. Right? So from here, can we come upon the derivation that speed at A, speed of rotation at A is going to be much higher as compared to speed of rotation at B, which is going to be much higher as compared to speed of rotation at C, which is going to be 0. Speed of rotation at C is going to be 0. We can say that, isn't it? So basically, that gives us an idea. Are we comfortable with this? That is why when the planet rotates, the region at equator will cover a very large distance. Then comes the region at B. Then the region of poles. So speed of rotation is going to be maximum for the planet around the region of equator. At the region of equator, the speed of rotation is roughly 1600 kilometers per hour. It slowly and steadily decreases. And by the time that we reach the region of the poles, the speed of rotation actually ends up becoming 0. So that is where, if I bring that to the question, the speed of rotation at any point on the equator is at the rate of approximately 1000 miles per hour, which comes out to be around 1600 kilometer per hour, decreasing to 0 at the region of the pole. Speed of rotation is going to be highest at the region of equator. Distance covered is less, so speed of rotation is going to be a little less here, and the speed of rotation is going to be minimum at the region of the poles. Okay, we are comfortable with that, right? Hussain and GIB, are we comfortable? Good. So Earth spins on its axis from west to east. That is, basically, consistently it rotates on a direction west to east. It takes the Earth close to around 23 hours, 56 minutes and 4 seconds to complete one rotation. That is the time taken to complete one rotation. That is what we call as 1 day, isn't it? So, but as the planet rotates, its axis is tilted. Its axis is not straight. Its axis is not vertical. Its axis is basically tilted. So here, if you think about the planet like this, here, now the axis is basically tilted. So here, what you have is that this axis is tilted from vertical at an angle of 23.5 degrees. This angle is 23.5 degrees. This has not always been consistent through the geological history of the planet. Throughout the geological history of the planet, this has changed multiple times. You will find few of the planets whose tilt is much more than that. You have few of the planets where the tilt is more than around 90 degrees, closer to 180 degrees in certain cases. If you talk about the planet Neptune, there the actual tilt is much more. There the actual tilt is almost to the opposite side. So this actual tilt, how is it decided? So it is decided right at the time of its formation, how the various different colliding forces led to the formation of the planet. So think about it. Let's suppose this is an object which is moving. It is rotating. It is hit by another object. Now, due to the force of the impact, it will have a kind of a tilt, that tilt, and then it will start rotating across that tilt itself because it is rotating in a vacuum in space. Then let's suppose meanwhile there is another force, another impact. Again, that tilt will be there. So like that, since the time of its formation, it has had multiple changes in the actual tilt. As of now, for a past considerable time, for the past few millions of years, and in fact, for the past few billions of years, the planet has had an axis of rotation closer to around 23.5 degrees. But this also keeps on changing ever so slightly every few 100,000 years. This also changes to around 24 degree or 21 degree, but we consider it to be 23.5 degrees. It is vertical tilt of 23.5 degrees and basically the horizontal tilt of 66.5 degrees. Together, if you notice, they make up 90 degrees. So that is the actual tilt. But what is the implication of it? The implication of it is that the circle of illumination will be present here. Okay, so you will have a situation where at one point of time, either the northern part of the earth is tilted towards the sun and the southern part tilted away from the sun. And sometimes, let's suppose the planet comes into another position, northern portion gets tilted away from the sun and so on. That is what gives rise to seasons, as we will take a look into it very shortly. So that is the case of the planet Earth as a rotating object. Now this planet Earth, as you can see here in this particular image, planet Earth moves in a kind of an orbit, elliptical orbit around the sun. Ellipse is different from a circle. Circle means that from the center all points are equidistant. That is the case of the circle. When we talk about an ellipse, it is not the case. Ellipse basically is somewhat like this. So that is where, if let's suppose you have the sun to be present here, the planet Earth continues to move around in an elliptical orbit. So there will come a point where the planet Earth will be farthest away from the sun. There will come a point where the planet Earth will be closest from the sun. But it keeps on moving in a kind of an elliptical orbit. And here in this image, if you observe carefully, observe the tilt. The tilt is maintained. The tilt is maintained here. So because of the tilt, you will have a situation that sometimes the northern portion of the planet appears to be what is referred to as a northern hemisphere. It appears to be tilted away from the sun. Southern hemisphere tilt appears to be tilted towards the sun. Now, as the planet comes into this position, northern hemisphere appears to be tilted towards the sun. Owing to that actual tilt, southern hemisphere appears to be tilted away from the sun. Okay, so while Earth is spinning on its axis, it is revolving around the sun in an anti-clockwise direction. It takes the Earth one full year to complete one full revolution around the sun. Now, the mean distance of the Earth from the sun is around 93 million miles, or close to around 150 million kilometers is the distance. Average distance is around 150 million kilometers. Okay, so because it is moving along an ellipse, you will have a position when the Earth is very far away from the sun. You will have a position when the Earth is closer to the sun, right? And that basically brings into equation the position what is known as aphelion and perihelion. Aphelion. So helion here refers to the reference of sun. Helion is derived from Helios. Helios is a reference to sun. So when we say the position of aphelion, Aphelion basically means the distance from the sun is the maximum. At this particular point, the distance of Earth from the sun is around 152 million kilometers. When we say that this is the farthest point away from the sun in the ellipse, and then a position will come where the Earth is around the shortest distance, that is around 147 million kilometers. So that position in its orbit when planet Earth is farthest away from the sun, that is what is known as aphelion. When we say that the distance is closest from the sun, that is perihelion. Similarly, when the moon also moves around the Earth, it is not circular. You will have a position where the moon is farthest from the Earth, and you will have a position when the moon is closest from the Earth. When the moon gets farthest away from the Earth, similar naming. Ap means farther here, and when we talk about the moon and the Earth, we use the term G because geoid, because Earth, right? So apogee represents the position when the moon is farthest from the Earth. Perigee, rather than perihelion, here between moon and Earth, you use the term perigee. So the term apogee refers to that position of the moon when it is farthest from the Earth. The term perigee represents that position of the moon when it is closest to the Earth. So that is why if you have ever witnessed the satellite launches that we carry out, that ISRO carries out, basically if you would have noticed the graph that they show on the screen, they show you apogee and perigee for each satellite, which tells you that in their orbit, in their motion, moon gets farthest away and then moon comes very close to each other. Right. So that is basically the case of aphelion and perihelion, apogee and perigee. When we talk about aphelion, this occurs generally on 4th of July. That is when it is farthest away, right? And is slightly closest around 4th of Jan. Okay, so 4th of Jan is when it will come closest. Now here, please don't get that kind of a confusion. But then in July, you are saying it is farthest, but we experience summer. In January, you are saying it is closest, but we experience winter. Why is it so? That is largely determined by the axial tilt, right? And that gives the rise to various different seasons, the variation in the length of day and night, as we will study and take a look into that. So Earth is at a maximum distance from the sun at aphelion and as its minimum distance at perihelion. Okay, the point on the moon's orbit where it is farthest from the Earth is called apogee, and when it is closest to the Earth, it is known as perigee. Okay, now then we come to the seasons on the planet. Why do we experience the various different seasons on the planet? So you would also have experienced, we are in the month of December, the midst of December almost. Now the length of day, what you are experiencing right now, would be different from the length of day that you experience in May. In the month of May, you would have experienced that sun rises much earlier and sunset happens much later. In the month of December, you would have experienced that the sun rises significantly later, sunset happens much earlier. So the length of the day during these months is shorter, length of night is longer. In summer, you experience length of day is longer, length of night is shorter. Why does that happen? Again, because of the axial tilt. How? Let's consider this. Let's suppose we consider this. Now each of these, they represent the circle of illumination. As you can see, the portion on the other side basically represents the daytime and the portion on the darker side represents the area experiencing nighttime. Now here, let's assume this is the equator. Equator basically divides the planet into two halves or hemispheres. Hemi means half, sphere, half of a sphere. So this is what is known as the northern hemisphere. This is what is known as the southern hemisphere. Okay. Now, if you consider this position, you will find, if you talk about the rotation of planet Earth from west to east, consider this and listen to this very carefully for the next 10 minutes. Listen to this very, very carefully for the next 10 to 15 minutes. Whatever doubts that you will have, etc., that will always be taken care of. So here, consider that northern hemisphere. In the case of northern hemisphere, this is the portion to the other side of the circle of illumination. This is the portion which is going to experience night, and the brighter portion will experience the daytime. Now, In this position, can we say in the northern hemisphere that northern hemisphere will spend more time in the lighted area, less time in the darker portion? We can say that because of the axial tilt, because of the position, can we say that the northern hemisphere will experience or will basically observe a greater amount of time spent in the lighted area and less amount of time in the darker area? Are we comfortable with this basic fact? Yes? Okay, good. So if we are comfortable with that, more time spent in lighted area means length of day will be longer. Less time spent in the darker area means length of night will be shorter. Isn't it? We can say that. So in this position, northern hemisphere, can we say northern hemisphere in this position will have longer days and shorter nights? What about southern hemisphere? When we talk about southern hemisphere, this is the circle of illumination. Can we say that southern hemisphere spends less time in the lighted portion and more time in the darker portion? We can say that. So in the case of southern hemisphere, we can say shorter days and longer nights. We can say that. Longer days means what? For a longer period of time, sun is shining. Means the ground will get heated up for a longer period of time. That means temperature will be higher. That means summer season. Longer nights mean and shorter days means what? It will be without sunshine for a long, so nights will be longer. Right now you are experiencing longer nights. So sunlight is for a shorter duration, nights are for a longer duration. Means winter. So in this position, northern hemisphere will experience summer, southern hemisphere will experience winter. Is that digestible? Are we able to digest this? Right? Perfect. Now, with the same axial tilt, planet continues to rotate. Now the planet will come into this position, then it will come into this position also. So in this position, as it comes here, this is your northern hemisphere, this is your southern hemisphere, right? Now, this is the circle of illumination which distinguishes day and night. Now, in this position, can we say about the northern hemisphere, it will spend shorter amount of time in light and more amount of time in during darkness? So, northern hemisphere, can we say shorter days and longer nights? Something that we are experiencing right now. We can say that northern hemisphere will experience shorter days and longer nights. What about the southern hemisphere this time? Southern hemisphere will spend more time in light, less time in darkness. So we can say that southern hemisphere will experience longer days and shorter nights. We can say that. So shorter days and longer nights, winter in India, Canada, US, the entirety of Europe, Asia, winter season is going on. Now, southern hemisphere, longer days and shorter nights. You will experience what? Summer. Australia, New Zealand, Argentina, South Africa, they are experiencing summer season as of now. So different parts of the planet experience different seasons. But what about this position and this position? Try to understand this carefully. Axial tilt is still there. Axial tilt, the axial tilt means tilt of the axis. Tilt of axis is still the same. But if you can imagine this as the axis of planet Earth, let's suppose you imagine this as a tilt of axis of planet Earth. If this is the sun, now this is the month, this is the situation of June. This is the situation of June when here you have the sun. The axis is such that the northern hemisphere is tilted towards the sun. The planet moves, comes here in the month of December. So northern hemisphere is tilted away from the sun. But what about this position in the month of September? In this position, or 6 months down the line in the month of March, in this position. In either of these cases, the actual tilt is still there. But what is the direction of the tilt? Can we say that northern hemisphere is tilted towards the sun? No. Can we say that the southern hemisphere is tilted towards the sun? No. Can we say that regardless of the actual tilt, both the sunlight will cover both the hemispheres equally? Sunlight will cover both the hemispheres equally in this case. Neither of the hemispheres are tilted towards or away from the sun. Both the hemispheres will be covered by sunlight equally. Can we say that? Right? That is where you will have the equal amount of sunlight spreading across both the hemispheres. So as the planet rotates, almost half of the planet will be lighted by the sun and equal half will be nighttime. So equal length of day and night. So this is basically the case of the various seasons. Let us elaborate upon that a brief. So this is the position which you experience in the case of winter months of the northern hemisphere. So this is your equator. Now here, this is your imaginary circle of illumination. This is your imaginary circle of illumination. Right? Now, this position is largely present all the way. If the planet is situated here, if the planet is situated here, here, or anywhere, you will have a situation where due to the actual tilt, the northern hemisphere is going to be tilted away, southern hemisphere is going to be tilted towards the sun, right? So in this case, during the months of October, November, December, January, February, northern hemisphere is tilted towards the sun. Southern hemisphere is tilted away from the sun. Away from sun. Okay. So in this case, northern hemisphere will have longer nights or shorter days and longer nights. Oh, okay. Here basically the opposite has to be written. Away from the sun. And the southern hemisphere is tilted towards the sun. Shorter days and longer nights. That means northern hemisphere will experience winter. We are experiencing winter season as of now because of this position, because the northern hemisphere spends very little amount of time in the lighted portion, more amount of time in the darker portion. That is why we have long nights within the day, within the 24 hours. Southern hemisphere will experience longer days and shorter nights. That is why southern hemisphere is experiencing summer as of now. The temperatures are higher. It is summer season in South Africa, in Australia. It is the summer season. Now the region of the poles. Region of the poles indicates something very interesting. For example, if you consider this as the North Pole, obviously it is the North Pole. It is not to be considered. It is the North Pole. This is the region around Arctic. That is the Arctic Circle. This is your North Pole. This is your South Pole and the region that is around it, Antarctic Circle. Antarctic Circle. And this is your South Pole. Now here, if you observe it, in one complete rotation, regardless of how many rotations they do happen, will the North Pole ever come into the lighted area beyond the circle of illumination? Regardless of in this position how many rotations you carry out, will the North Pole come into the lighted area? What do you think? Will it come into the lighted area? No, it won't. Because as the planet is rotating in the tilted axis, and this is the portion of circle of illumination, it will always be in darkness. So that is why during these months, almost for the entirety of the period, the region of Arctic experiences permanent nighttime. Sun doesn't even rise up. That is where in the region close to the Arctic Circle, in the Arctic Circle, for example, right now, the region around Norway, the region around Greenland, northern portions of Canada, they would be experiencing permanent nighttime, no daytime at all, no sunlight at all. So the region of the poles, they experience almost 6 months. North Pole at this time experiences continuous nighttime for almost 5 to 6 months. Very cold conditions, very, very cold conditions. This is the reason why polar bears, they go for that long winter sleep where they basically don't move, they simply sleep in the same place for the entirety of the period because it is very cold and darkness. Then, what about the region of Antarctica at this stage? Antarctica and the Antarctic Circle, regardless of how many rotations they do happen, regardless of how many rotations happen, will it ever come on the darker side of circle of illumination? No. It will consistently be on the brighter side, isn't it? It will consistently be on the brighter side. That is why during these months, Antarctica experiences continuous sunlight. It is not, when you think about sunlight, the problem is because we live in an area which has got high amount of sunlight. When we think about sunlight, we think, okay, 2 p.m. in the afternoon, 1 p.m. in the afternoon, what amount of sunlight is there? No, that amount of sunlight is not there. But the kind of sunlight that you see at maybe 7 a.m. or 6 a.m. in the morning, or around 4 p.m., 5 p.m. in the evening, when the sun is very close to the horizon, very close to the kind of sunset or sunrise, it is in a slanting position. Antarctica permanently experiences this condition during this time. This is the time of the Antarctic summer. This is the time when the region around Antarctica, the coastal areas of Antarctica, they start melting. The penguins become active, and all the polar expeditions to Antarctica, that happens during these months because it is Antarctic summer which is going on. Right? So in this case, you will not have any nighttime, no nighttime in the region of Antarctica, in the region of South Pole. You would be aware of this earlier also, but many of us would not be aware why this happens. This happens because of the axial tilt of the planet. Okay, so in the region or during the months of October to February, Arctic Circle and beyond, no sunrise, continuous night. Antarctic Circle, no sunset, sunset, continuous day. Right? That is the case during these months. Now, if you have noticed in your area itself, wherever you are living, you would have experienced that right from the month of October itself, the days they start getting shorter and shorter and shorter. In the month of October, maybe the sunset would be happening at 6 p.m. in your region. Now the sunset would be happening at 5:30, at around 5:45, 5:30, 5:20 itself. The days they get shorter and shorter. Around the time of 21st of December, 21st to 22nd of December, which is going to come within a week. So around that time, 21st December, that is when Northern Hemisphere experiences shortest day and longest night. Southern Hemisphere during the same time will experience longest day and shortest night. This is the condition known as solstice. This is what is known as winter solstice in northern hemisphere or December solstice. Solstice or winter solstice in northern hemisphere. So if I ask you, on 21st of December, what is the duration of sunlight in the region of Arctic? Out of 24 hours, on 21st of December, what is the duration of daytime in Arctic? What will be your answer? Very good. Beautiful. 0 hours, no daytime at all, no sunrise at all. So it will be permanent night in the region of Arctic as of now. So on 21st of, around the time of 21st of December, no sunrise at all, permanent darkness, right? That is where even the human habitations, very few people live around the region of Arctic Circle, but those of them who live there, they are adapted to this lifestyle. They are adapted to this lifestyle of such continuous darkness. In fact, many of them, because it is a phenomena that many people across the world, they are not very well aware of. Many of them, they have started their own YouTube channels and are earning, minting millions of dollars of money worth of it just by showing the people that, look, today also it is only night, no sunrise. Tomorrow also it is only night, no sunrise. But this is a phenomena which will go on for 6 months, right? So that is the case of the solstice. Now, after this, we come to the position here where we saw this particular position, where the actual tilt is neither towards the sun nor away from the sun. It is in a different plane altogether. So in this position, this is the axis that is in the month of March, something that you experience also on September. This is your equator. The earth is tilted like this. The sun is on some. So if the earth is tilted like this, the sunlight is coming here. So the circle of illumination almost divides the planet in equal parts, halves, right? So in this case, when we talk about the rotation of the northern hemisphere, that is experienced in March, especially 21st of March and September, around 23rd of September. Why only March and September? Because if you take this entire movement to be 12 months, this will be 4 months, this will be 4 months, this will be 4 months, or 3 months, 3 months, 3 months, and 3 months. Right? So after December, 3 months March, after that June, after that again September, like that. So in the case of March, you will observe, if you talk about northern and the southern hemisphere, can we say northern and southern hemispheres are neither tilted towards the sun nor are they tilted away from the sun. Can we say that? Neither it is tilted towards the sun nor away from the sun. Now we can say that this northern hemisphere will spend equal amount of time lighted and equal amount of time in dark. Same is the case with southern hemisphere. They will experience equal amount of time in light and equal amount of time in darkness. So in this case, length of day equal to length of night. You'll find 12 hours day and 12 hours night. This is a condition which is referred to as equinox. I will address all the questions once we get done with the portion of the seasons. Don't worry here. I will answer the questions. So even in the polar area, some amount of light starts coming in. Right? Some amount of light starts coming in. Okay? Now, then, after 3 months again, when we consider the conditions of June, here, this is your circle of illumination. The tilt is now clearly towards the sun of the northern hemisphere. If you consider this to be the equator, this is your portion of northern hemisphere. This is your portion of the southern hemisphere. This is the region of North Pole. This is your region of the Antarctic Circle or the region of South Pole. Here, this is your Antarctic Circle. This is your Arctic Circle. So, in these months, that is right after the position of March, all the way till the position of September, that is for the months of April, May, June, July, and August. This position will be largely maintained. We can say northern hemisphere is tilted towards the sun. The sun. Southern hemisphere is tilted away from the sun. So that means northern hemisphere will spend more time in the light and less time in the dark, right? More time in the light means summer months. Northern hemisphere experiences summer. Southern hemisphere will experience less time in day, more time in dark. Southern hemisphere will experience winter. So when India, China, Asia, entirety of northern hemisphere experiences summer, Australia and the regions thereby are frozen, or not frozen exactly, but they experience winter season, very cold winters. Okay, but what about the polar areas here? In this case, look at the region of Arctic Circle. Arctic Circle in this case position, regardless of how many rotations it goes through, Arctic Circle basically will always be lighted. Will it come to the other side of the circle of illumination, to the darker side here? No. Arctic Circle will always be lighted. In the case of the Antarctic Circle, regardless of how many rotations it goes through in this place, in this position, it will be always in darkness. This is when the Arctic goes through the Arctic summer, or the melting of the Arctic happens, and you have 6 months of continued daytime. And the Antarctic region goes through the frozen period of very cold winter, where it is permanent darkness, permanent nighttime. So this is where in the month of April to August, here, Arctic Circle, sun does not set, continued daytime, then Antarctic Circle, sun does not rise, continued night, right? And in the summer season, recall it from your own experiences. You would basically have experienced from the month of April, length of day, whatever is there. In the month of May, daytime gets longer. In your childhood days, when you would have gone out to play in the evening, you would have experienced that during the summer vacations, you would have had a longer playtime because the sunset would happen later, isn't it? On 21st and 22nd of June, 21st of June, Northern Hemisphere experiences longest day and shortest night. Whereas the Southern Hemisphere experiences shortest day and longest night. This is what is the June solstice or the summer solstice in the Northern Hemisphere. Solstice in the Northern Hemisphere or the June solstice. So if I ask you the question that on 21st of June, what is the duration of night time in Arctic? What will be the duration of night time in Arctic on 21st of June? What do you think? 0. Perfect. So on 21st of June, Arctic will have continuous daytime, right? Antarctic will have continuous nighttime. Now, all those of you who have the question that in which direction is the tilt there, sometimes you are showing the tilt in this direction, sometimes you are showing the tilt in this direction. Please let us know here itself whether it is east or west so that we can have peace of mind. Understand, east or west is basically our interpretation from planet Earth. We are standing in a place of planet Earth, so that is why we have the liberty to think east or west. Tilt is always in one direction itself, from whichever side you take a look at it. But here, think about it and look at this image carefully again. All those of you who were asking this question continuously, tell me the direction of the tilt, tell me about the direction of the tilt. Observe this image. The tilt is consistent in the same direction. Tilt is in the same direction. So you questions were asked by Twisha, Nikat, Kanchan, Jyoti, all of you who were asking about consistently which direction is the tilt. Tilt is always in this same direction. If you are looking from this side, it might appear to you that the tilt is in eastward direction. If you are looking from this side, if let's suppose you are standing here and looking at it, the tilt might appear to be opposite, but the tilt is the same. But because the planet rotates in such a way, our planet moves around the sun, so you will have a position of the planet. If this is the tilt, actual tilt, again, observe this carefully. If my fist here represents the sun and this pen represents the actual tilt, so when the planet is here, it will appear that the tilt is towards the sun, the northern hemisphere is towards the sun. But if the planet rotates and comes here with the same tilt, it will appear that the northern hemisphere is away from the sun. If the planet comes here, neither of them is tilted towards or away from the sun. Both of them get equal rays. If it comes here, northern hemisphere appears to be tilted towards the sun. If it comes here, neither of them are tilted towards or away from the sun. Both of them get equal rays. If they come here, it is the southern hemisphere which is tilted towards northern. So the tilt is the same. It is due to the location here where you get that kind of an exposure. Is that understood now? Right? Jyoti, Twisha, Kanchan, Hussain, all of you. Good. Now, that is the case. So because of the actual tilt of the planet, because the planet is tilted on its axis, that is why different areas, they experience different duration of day and night. Had the planet not been tilted on its axis, let's suppose the axis would have been vertical, then in that case, all the regions would have experienced equal duration of day and night. This is the reason why during the time of the summer season, during the month of the summer, if you go to the region to the North Europe, northern portion of Europe, for example, northern portion of Canada, northern portion of Asia, for example. Now here, what will be the pathway? If I can represent the pathway of rotation, I can say that this is the path of the rotation. This is the path of the rotation. This is where it goes. And it spends very short time here. That is why during the summer months in the region of Northern Europe, you know when the sunset happens? The sunset happens sometimes at 12 a.m. at night, sometimes even 1 a.m. at night. The sunset happens. Here we are used to a life from our childhood days. We are used to a life where at 5 p.m. or 6 p.m. it becomes dark. Imagine a life where it gets dark at 12 a.m. 11 p.m. also it is bright outside. 10 p.m. also it is bright outside. And then again at 5 a.m. in the morning it becomes brighter. Right? So in certain areas you will have 10 hours or close to around 20 hours of daylight and only 3 to 4 hours of night time during this condition. Okay, so it is because the actual tilt of the planet, different areas get different duration of day and night. Okay, yes, Abhay, that is the case. Right? Now, after this, we come to the case of longitude and latitude. Okay, March equinox, September equinox, again explain. Okay, very elaborate a question. How the position of the sun experienced in case of no sunset. So in case when there is no sunset, let's suppose you are standing here, then the sun will be somewhere not vertically upwards, but very in a slanting position, very close to the horizon. So very slanting position, that will be the consistent position of the sun. Okay. And when we talk about the Garima, your question, equinox virtually means equal amount of day and equal length of day and equal length of night. Garima, March equinox and September equinox explain. So the case is that, see, here also in the month of March, the tilt is there. The tilt is there. But again, take a look at this. Carefully look at this. Patiently look at this. If the Earth is in this position, one of the hemispheres is tilted towards the sun. I hope you understand this is the axis. One of them is towards the sun, one of them is away from the sun. What if with the same tilt, the planet is here? None of the hemispheres are tilted away or towards the sun. Both of the hemispheres get the equal rays of sun, isn't it? So the same condition here, this is your position of the sun in this case. This is the position of the sun. This is the tilt. So basically, both the hemispheres will get equal amount of sunlight because neither of them is tilted towards or away. So equal amount of sunlight means the circle of illumination will almost be passing through half. Equal length of day, equal length of night. Okay? Right? Now, after this, when we talk about the case of longitudes and latitudes. So basically, see, rotation and revolution. Rotation means when it is moving across and around its axis. That is rotation. Okay? When we say it is moving around the sun, that is revolution. Okay? Now, when we talk about latitudes and longitudes, so basically, these have always, latitudes have been in existence for a long period of time. These are imaginary circles and imaginary lines which are drawn. When we say a latitude, so it came into existence in order to help understand the location of a place, positioning of a place. In older days, in ancient days, when the mariners, when the sailors would travel large distances, they would require certain references and they would navigate with the help of the position of the stars and the position of the celestial objects. That is what would help them navigate and move from one place to another. And for that, they needed reference pointers on the surface also, and that is where they used the imaginary lines or the imaginary circles. That is what your latitudes are. So latitudes are circles of parallels, parallel circles which don't meet with each other. These are your latitudes. They are parallel circles. Okay, the largest latitude is the one which passes through the central portion of the planet Earth. That is what is known as the equator. It is that equator which divides the planet into northern hemisphere and the position of southern hemisphere. Now, what about longitude? So longitudes came into existence in order to keep a track of time. Different areas, they experience sunrise at a different point of time and sunset at different point of time. For example, Japan, which is referred to as the land of the rising sun, Japan would experience sunrise much earlier as compared to India. Right now in India, we are experiencing night time. Is it the case that across the world it is night time? No, obviously not. In the region around, let's suppose UK or Britain, right now it will be somewhere around in the afternoon, right? 3 p.m. or 4 p.m. in the afternoon. Then somewhere in the region of US, it would be early morning right now because the planet is consistently rotating from west to east. So if India is here, as India moves to the darkness, some other region will come into brightness. So every area of experience is different time. So when we say an event has occurred at 5 p.m., 5 p.m. where? 5 p.m. in India, 5 p.m. in China, 5 p.m. in Russia, where? So for those purposes, basically you needed a standard reference time. Many countries, they started following the reference time of UK and Britain because in the 1800s you had the British Empire at one of its peak. So basically British Empire was very, very powerful. So the Postmaster General in London, which was a very powerful post also, he basically said that, look, we have these imaginary circles, we draw these imaginary circles across the planet also, north to south imaginary circles. And basically, let us consider the circle which passes through the Royal Observatory in Greenwich, close to London, as the standard circle, the standard longitude. The time observed here will be considered as the standard time. The rest of the clocks across the world will be adjusted as per the standard time. So that is what the longitudes are. And the one passing through the region of Greenwich in London, near London rather, that is what is known as the prime meridian. And all of them are basically a mere referencing to that. So the portion which lies to the east of it, that is also what is referred to as Eastern Hemisphere. The portion which lies to the west of it, that is what is known as Western Hemisphere. Okay. So basically, that is the concept of latitudes and longitudes. But how are they named? You oftentimes hear about the naming 10-degree east, 90-degree north, or 50-degree north, 60-degree south, 20-degree north, 30-degree north. How does this latitude and longitude get numbered? Basically, if you consider the latitudes, let's suppose you have to name this particular latitude here. You have to name this particular latitude. How do you name this? Whether it is 30-degree, 40-degree, 50-degree, how do you name this? So for that purpose, the reference is considered from equator. Equator is considered the reference point, or because it passes through the center, it is considered to be 0-degree here. Now from that region, you draw a line to the center of the planet, imaginary center obviously, and then you join it with the latitude in question. You join it with the latitude in question. You measure the angle. Let's suppose this is 40 degrees. So it is to the north of equator. So this will be, the latitude will be named 40-degree north. Right. Let's suppose you have to name this particular latitude. This particular latitude. How do you name that? You again join a line to the center here. If it carves out 50 degrees, let's suppose 50 degrees. So this will be 50-degree, but it is to the north of equator, 50-degree north. Let's suppose similarly, I have to measure this angle or this particular latitude. Let's suppose. What will I do? Again, I will join this to the central point here. Let's suppose this makes 20-degree as an angle. So this will be named as 20-degree, but it is to the south of equator, 20-degree south. That is how basically they are measured. Okay, some of the important latitudes basically are, you will have the Tropic of Cancer, Tropic of Capricorn. So equator is 0-degree. Tropic of Cancer, which passes almost to the center of India, that is 23.5-degree north. Tropic of Capricorn is 23.5-degree south. Arctic Circle is around 66.5-degree north. Antarctic Circle is around 66.5-degree south. And the poles, they are considered 90-degree north and south. Why? Because again, with the same logic, if let's suppose I apply the same logic to the region of the poles, if I draw an imaginary line here, what will be the angle made? 90 degrees. So this is 90-degree north. Similar logic in the case of measurement of longitude also. So latitudes are your imaginary circles parallel to equator, right? They are named after the angle created by a line connecting the latitude to the center of the earth and the line connecting the equator and the center of the earth. So whatever is the angle created, that is basically considered to be that angle of latitude. When we talk about the longitude, in terms of longitude, basically here, how do you measure that longitude? So here, the prime meridian is considered to be 0-degree longitude here. This prime meridian, that is considered to be 0-degree here. Right. Now here, let's suppose I have to measure what is the angle of this longitude which passes through North America. Let's suppose. Now what do I do? From the central point of that longitude, I draw a line to the center, and here also I draw a line to the prime meridian. I measure the angle. If this angle comes out to be 120 degrees, suppose, it is to the west of prime meridian. So this will be your 120-degree west. Right. So that is how the naming and the numbering of longitudes and the latitudes, they happen. So if I gain a top view, let's suppose you are watching it from here. I gain a kind of a top view into this. So if I gain a top view, how will this appear to look like from above? It will give me an appearance somewhat like this. where all the longitudes will actually be crisscrossing each other? All of them will crisscross each other, isn't it? All of them will crisscross each other. Right? So, if let's suppose, and here again, I want you to exercise your brain and apply simple logic, even though sometimes simple logic is what defies us. If let's suppose this is your prime meridian, which passes through Greenwich in near London, if this is considered to be 0 degree, what will be this angle? Apply logic. If this is your 0 degree, what will be this angle? Can we say it will be 180 degrees? Can we say it will be 180 degrees? Right? Simple logic, guys. This is 0 degree. This will be 90 degrees. This will be 90 degrees. This will be 120 degree, 140 degree, 160 degree. Can we say that this will be 180 degrees? Roshan, is that understood now? Okay. Now, if it is 180 degrees, that is the exact opposite of prime meridian. This is what is also known as anti-meridian. Anti-meridian. Okay, that is what is known as anti-meridian. So in between 0 degree and 180 degree, the planet again gets divided into two equal halves. This is what is known as the eastern hemisphere. This is what is known as the western hemisphere. Okay, right? So that is the case of longitude. So longitudes are geographical positioning markers that run from geographical North Pole to the geographical South Pole, intersecting at the region of equator. They meet at both the poles and specify the east to west position of a place. Prime meridian is set as 0 degree longitude, and it divides the earth into eastern and the western hemisphere. All other longitudes are measured and named after the angle they make with the center of the earth from the intersection of meridian and equator. That is how the naming and the numbering happens. International dateline basically is again closer to the region of anti-meridian. You have a line which distinguishes one day from the next, which differentiates, let's suppose, 13th of December from 14th of December. We'll cover it tomorrow. So basically, today we will limit it here. But before that, I want you to attempt this question, which had been asked in the prelims examination. On 21st of June, the sun does not set below the horizon at Arctic Circle, does not set below the horizon at Antarctic Circle, shines vertically overhead at noon on the equator, shines vertically overhead at the Tropic of Capricorn. So what happens on 21st of June? Weber, when we see sunset, why we see the image of setting sun in river and not on land? Are you able to see the image of anything on land, Weber? On river, you will be able to see the image of buildings also. But on land, are you able to see the image of anything at all? That basically explains your question there itself. So, majority of you have given the correct answer in this case. So, on 21st of June, the region of Arctic experiences continuous daytime. So, we can say that the sun does not set in the Arctic Circle. Right, on 21st of June. In 21st of December, the sun will not set in the Arctic. But on 21st of June, it basically will be that it does not set in the region of Arctic Circle. Okay, I hope that is understood. What is the concept of horizon? Leaderboard, everybody would have got, most of them have got correct this in this case, so there's no point of that. This is your leaderboard. Horizon basically is the case when you say that you would have seen, or if I draw it out here, if you have these buildings, you observe the sun rising from here, the sun rising from here, right? After some time, the sun gets bigger, isn't it? So this imaginary point where the sky appears to be meeting the surface, the ground, that is what is known as the horizon. Okay, this is what in Hindi it is also known as Kshitij. So that is basically your horizon. Twisha, is the question not understood? Is the question understood now? How many of you have not understood this particular question? Okay. So basically, on 21st of June, can we say that the Arctic Circle sun does not set? Is that understood now? Roshan, GIB, Anjali, Yug Singh, Twisha, Shashi, Shweta, Lakshmi. All of you. Is that understood? Right? So if we say that the sun does not set, on 21st of June, the sun does not set in the region of Arctic, what does that mean? That consistently, if this is the land surface, consistently sun will be shining from here. It will not set below the horizon. It will always be there. So that is the answer. Right? It's solved now? Okay. Sushmit, C point basically, see, at the point of equinox, you have the sun which is shining equally in northern and the southern hemisphere. So we say that it is vertical over the region of equator. Don't worry. I am assuming that many of you are going to study geography and many of you are studying geography for the first time. Have patience. Don't lose your patience. Slowly and steadily, we will cover this. Don't worry. Is it true that in polar there are 6 months day and 6 months night? Yes, almost. So see, it is not exactly 6 month day, 6 month night, but the sun starts coming up during the time of the equinox and the sun starts setting at the time of equinox also. So you can basically reduce 1 month out of that. So more or less. And yes, Megha, you can. And Vaibhav, if the sun is rotating and earth is also rotating, then always the same part of earth should, why that should be the case? Movement of sun is very independent from the movement of earth. In the case of moon, it is the case that the distance is so close and so near. That is why the same face of the moon is held by the earth. But in the case of sun, it is far away. Okay. According to Kepler's law, when earth is at perihelion, its angular speed is high. Because of this, it experiences less duration of, can we also say this? No. But see, temperature, Ashish, is always dependent on many of the factors. When we come to climatology, we'll talk about the temperature. Solar insolation or the solar energy is just one of the factors which influences the temperature. If the northern hemisphere is tilted away, and regardless of what is the positioning of the sun, solar energy can differ, but the wind pattern, etc., duration of length and night, all will be different. Okay. And is there any conflict between expanding force and pull of sun on earth? Can we say that expanding force also plays a part in keeping the earth? No. That expanding force, we are observing stars moving, galaxies moving away from earth. When we talk about at the level of the universe, sun and earth, they are very close to each other. So it is not going to be the case that there is nothing keeping the earth from falling onto the sun. Earth is consistently being attracted by the sun, but because it has got energy and force, that is why it moves in circular motion. Viveka, it is sufficient. You will study some more concepts about stars, etc. in the portion of science and tech. If a person is on pole, he never moves, always on the same position. Yes, if you consider the rotation, yes. During Big Bang, which collision occurred in Earth? During Big Bang, you did not have planet Earth in existence. You did not have the solar system in existence. Solar system came into existence almost 8 billion years, 8 to 9 billion years after the Big Bang. Okay. Just attend the sessions, Twisha, and please revise the sessions, more than sufficient as of now, and read the newspapers. So that will be all for today. We meet again tomorrow, where we continue, and then we will carry on with the formation of the planet Earth and the portions of geomorphology. Okay.